first chapter, that is laws of motion, we have seen some things. Those are distance and displacement. The difference between distance and displacement. What is the difference? Distance is the total travel distance, while displacement is the actual distance, that means minimum distance. Afterwards we have seen speed. What is speed? Speed is nothing but distance upon time, that means the distance covered per unit time, that is speed. Afterwards we have seen the velocity. What is velocity? That is displacement per unit time is nothing but velocity. Afterwards we have seen the acceleration. Acceleration is the change in velocity per unit time, that means the final velocity minus initial velocity divided by time. And afterwards we have seen the graphical representation, that means the graph for uniform motion, uniform velocity and uniform acceleration. In this video we are going to learn the equation of motion. There are three equations of motion. Who discovered? Isaac Newton gives us these equations. Suppose these displacement, velocity, acceleration and time is related with the object which is moving along a straight line, then the initial velocity of that object is u, v is the final velocity, t is time, a is acceleration and s is the displacement by that object. Then the equation of motions are given as, or can be written as, v is equal to u plus at. Here there is a relation in between velocity and time, that means the relation between velocity and time is the equation of motion, first equation of motion given by Newton. S is equal to ut plus 1/2 at square, that is the relation in between displacement and time, that is the second equation of motion. And third one is v square is equal to u square plus 2as, that means the relation in between displacement and velocity. These are three equations of motion given by Newton. We are going to prove by the graph these equations. See, let an uniformly accelerated object, that means one object is moving or accelerated with uniform acceleration, then the initial velocity of that object is assumed as u and the final velocity is v, and the time taken to reach at a certain point is t. Plot this graph, time versus velocity. Take time on x-axis and velocity on y-axis. Suppose that object is moving from this point, that means the initial velocity is u, and reaches up to this point, that is point B. At that time the velocity of that object is v, that means u is the initial velocity and v is the final velocity of that object. V is the final velocity, here u is the initial velocity. Suppose we draw perpendicular from this point B on x-axis and y-axis, that means BE is perpendicular to OE, that means BE is parallel to y-axis, that is OC parallel BE. In this way, if there is a perpendicular from B on x-axis, that is BE perpendicular to OE, that means BE parallel to y-axis and BC parallel to OE, that is x-axis. Suppose that BE cross at point A, then acceleration is the change in velocity per unit time. We know that formula, acceleration is change in velocity per unit time. what is the change in velocity? That is from u to v. That is initial velocity is u and final velocity is v. That means the change is v minus u divided by time t. That means acceleration a is equal to v minus u. Here what is v? The distance from O to C, that is OC. And what is u? The distance from O to D, that is distance OD. Then OC minus OD divided by time t. Then take this t in this side, that means a into t, that is at is equal to cd. What is cd? OC minus OD. See here, OC from O to C minus OD, this distance O to D. Remaining part is CD. That means AT is equal to CD. Assume at this equation as 1. Then by graph we know that this BE is parallel to y-axis and BC is parallel to x-axis. Then by graph BE is nothing but BA plus AE. That means AE plus AB. Then what is AB and what is AE? We know that OD, V is equal to OD plus CD. V is equal to, that means this distance is OD, this distance plus this distance. That means this is U and this total distance is AT. See here, AT. CD is AT. How? From equation 1. CD is AT from equation 1. Then V is equal to U plus AT. We get the equation final velocity is equal to initial velocity plus AT. That means V is equal to U plus AT. This is the first equation of motion given by Newton. This is Newton's first equation of motion. Thank you.